Hello and welcome to the Robot Virtual World Level Builder Turning Challenge. What you see here right now is a VEX IQ Clawbot virtual robot, and what I am showing you here is that we are able to see a beam, a measuring beam, by clicking on the Show button on the right hand side. So that enables me to drop pins, distant pins, so that I am able to measure the distance that I want my robot to travel to. In order to fully see those distances, though, I'm going to switch to camera fixed top down, camera 2, because it's much easier to see the grid. I'm going to click on Add, and I am going to click on this position right here in order to drop a pin that I want my robot to go to. So now I see that the robot is going to travel 1.8 meters. There is a differential of a negative 0.09 on the angle of the robot. The bottom number is an angle, and that tells me that where I have dropped that pin, it is a little bit off in terms of the center of the robot, but for the purposes of this particular um, activity, that is fine for traveling down this corridor. What I need to show you right now is that I have my robot C program, and I've used the graphical interface rather than the natural language. The natural language is written in pure C, but I am able to do this from a graphical standpoint, and I am dragging and dropping these little tiles that tell it forward, etc., backward, turn left, turn right. So I've moved forward over here, and I've input the number 9 because we know that this is 1.8 meters away. By our calculations, we know that based on the radius being 3.2 centimeters and the diameter being 6.4 centimeters, we are able to travel 20 centimeters with one rotation. So 1.8 meters divided by 20 centimeters will give us 9 rotations, will get us to that pin. I'm going to compile the program by clicking this compile button, and I'm going to download to my virtual robot. So we see that my compiler target is virtual worlds. I can compile the same thing to a physical robot by simply tethering it to a USB cord that it comes with, the physical robot comes with. So by attaching it to my laptop, I'm able to download to the physical robot. But right now I am downloading to the virtual robots. Now it's ready to go. So when I click on play, I am able to see that this robot is traveling to the pin, and I will be ready to turn this robot left so that I can go to my next pin. So I see that it's just 0.11 meters away, a little differential of a negative 1.15 that it had traveled across the board. But I do see that now I am able to drop a pin, an additional pin, so that I am going to be able to have the robot go to this point and get ready for the turn down this next corridor. However, what I want to emphasize here is that I have to make a left-hand turn, and I'm going to have to calculate the number of degrees based on the size of the axle of the robot. Every robot's axle, every robot make axle is different, so I have to do a 90-degree turn, and that's a different number of rotations of that axle for each robot. So we'll cover that in the next video.